Hey everybody, Dr. Phil here. So this is going to be a video on a survey of basically concepts as it relates to probability. So let's go ahead and jump into what we mean by probability. So you've probably heard that word. If something is probable, if something's going to happen, usually means, it's likely going to happen. In statistics, probability speaks to a value between 0 and 1 that represents the likelihood a particular event happens. So if you can see on this continuum here, right, probability our sun will disappear this year is from 0 all the way up to chance of rain in Florida this year. If you've been to Florida, you know how humid it is. Pretty good chance of that, right? So basically, the closer to 1, the more likely it's going to happen. Let's with a couple more definitions. When we're dealing with an experiment, we think about a process that leads to the occurrence of one and only one of several possible results, right? The outcome is the result of the experiment, and the event is a collection of one or more outcomes of an experiment. So, as if we use one of the examples down here, the experiment is roll the die and then count the number of members of the board of directors for Fortune 500 companies who are over 60 years of age, right? So everything here is, probabilistically speaking. So what about some approaches to assigning probabilities? So classical probability is based on the assumption that the outcomes of an experiment are equally likely. So the probability of an event is just the number of favorable outcomes divided by the number of all possible outcomes. So for example, rolling a six-sided die once, what's the probability of getting an even number? And obviously, if you think about it, there's three even numbers, 2, 4, and 6. So just 3 over 6. And obviously, the would be zero point 0.5, or you could just say the probability of getting an even number when you roll a six-sided die is 5, 50%. So a challenge is to determine the values in the numerator and denominator. So of course, the small number of outcomes is easy to count. Think about like heads and tails, the die example we just saw. If the experiment is complex, there are many possible outcomes. Okay, so to help us with that, there are three formulas to help determine the number of outcomes. The first is what we call multiplication. Think about multiplying. The second is what we call permutation, and then the third is combination. Okay, so let's take a look. So let's suppose that there are n possible outcomes of an event. And let's suppose there are n possible outcomes for another event. So the total number of arrangements of the two outcomes would just be simply n multiplied by m. So this would be an example of multiplication. Now this can be extended to any number of events. So for example, if we pick three, lottery where three tumblers each with balls 0 to 9. After tumbled, one ball is selected from each. So what is the number of possible outcomes? And it would just be 10 times 10 times 10. And of course, that would give us, if you can do it on the calculator if you want, put in 10, multiply by 10 is 100, times 10, and there's your 1,000. So what if there's a single group? Well, if there's a single group, we can determine the number of all possible arrangements of an outcome for the group. So in the case of permutation, this is going to be any arrangement of, in this case, R objects selected from a single group of n possible objects. Okay, and this formula, as you can see, is determined by the multiplication formula. Right, so think of P is the probability, and then you can see if you look on the numerator here, we have n minus R simplified. So let's look at an example. So let's say a media company is producing a 1-minute ad video. In the production process, 8 different video segments were made. They can select only 3 segments. So how many different ways can the 8 video segments be arranged? Right, so we know n equals 8 and obviously R equals 3. So if we basically just plug in our numbers, so we can see we've got n over n minus R. So n is 8 and then 8 minus 3. So just think of it as 8 over 5. And then now what they're doing here is it's basically 8 times 7 times 6 times 5, so on and so forth, and then over the 5, and we get 336. Now, if the order of the selected objects is not important, any arrangement is called a combination. So ABC in this example would be, the same as BAC. Okay, the number of combinations is less than the number of permutations. Okay, so a combination is an event of outcomes when the order of the outcomes it doesn't matter. Right. So the permutation formula, we see it below, it basically just overcounts the And then we can see we're dividing out the overcounting if we look at the formula below. So let's take a look at an example. So the Grand 16 movie theater uses teams of 3 employees to work the concession stand each evening. There are 7 employees available to work. How many different teams can be scheduled? So you can see again, it's just a case of plugging in our numbers. The 7 employees are there. And then you can see on the bottom, we've plugged in the 3 and then 7 minus 3. And then the answer we get is 35. So basically, there's 35 different teams that could be scheduled based on teams of 3 and 7 employees being available to work. All right, empirical. When you hear the word empirical, just think about sort of like observations, like sort of seeing something. So empirical probability is the second type of probability. It's based on observation. So again, think about observation, seeing things, like I said, counting and recording experimental outcomes. Empirical probability is defined as the probability of an event based on a collection of observations or data. And empirical probability is based on relative frequencies. So the formula we use for empirical probability is the number of times the event occurs divided by the total number of observations. So as an example, the Standard & Poor's S&P 500 stock index was down 4 times over the course of the previous 20 years. So what's the probability that the index will be down next year? So if we let A represent the even of a negative yearly return, or the event of a negative yearly return, then we would say P, so A, number of times the event occurs is 4, total number of observations is 20, so basically just 4 over 20. So that would obviously be 20%. So we just said there's a 20% probability it may be down next year. Now, if there's little or no experience on which to base a probability, then we would estimate it subjectively. So an individual evaluates the available opinions and information and then would have to assign a probability. And of course, this is a little more subjective. So the subjective concept of probability is the likelihood or probability of a particular event happening that's assigned by an individual based on whatever information is available. So with respect to rules of addition, so the first is mutually exclusive. When we say that, what we mean is the occurrence of one event means that none of the other events can occur at the same time. So if they can't both happen at the same time, you either pick one or you pick the other. Collectively exhaustive means at least one of the events must occur when an experiment is conducted. So if the outcomes are A, B, C, one of them has to happen. It can't be that none of them happen. So if events are mutually exclusive, the special rule of addition is basically the probability of A or B equals the probability of A plus the probability of B, and so on and so forth. And this formula will work for any number of mutually exclusive events. So here we can see like event A and event B and event C, and again you notice that there's no overlap because it's sort of like this one, or this one, or this one. So let's take a look at an example of the rules of addition. So a machine fills plastic bags with a mixture of beans, broccoli, and other vegetables. Most of the bags contain the correct weight. Because of the variation in the size of the beans and other vegetables, a package might be underweight or overweight. So as we can see, underweight would be event A, satisfactory is event B, overweight C, and then we've got 100 packages underweight, 3,600 satisfactory, 300 overweight. And then here you can see how we're calculating the probability of occurrence. So like here, to get the 0.25, we could just do 100 over 4,000, give you that. 3,600 over 4,000 would give you the 0.9. 300 over the 4,000 would give you the 0.075. And obviously this has to equal to 1. So what is the probability that a particular package will be either underweight or overweight? So all we're going to do is we're just going to add the 0.025 plus the 0.075. We'll ignore the satisfactory 0.9. So then obviously the answer would just be 0.1, or you could just say 10%. So the complement rule is used to determine the probability of an event happening by subtracting the probability of an event not happening from 1. So the probability of A plus the probability of around A equals 1. So P to the probability of A equals 1 minus P. So basically, that's kind of a long way of just saying we're just subtracting the probability of something not happening. Everything up until now, it's been about the probability of it actually happening. What about it? What about it actually not happening? So if we refer to the previous example, right, what is the probability that a particular package will be satisfactory? And obviously, we know that we can just look straight here and go, okay, well, obviously it's zero point 0.9, right? Because we know that everything that's not satisfactory is 0.025 underweight. So just think of that as 0.25 or 2.5%, and then 7.5% overweight. So if you just add those together, think about one being the whole thing minus zero point 0.1, which is the 0.075 and the 0.025 added together, and that's going to give us the 0.9. So we're just basically we're getting the same answer that we would have gotten. This might even be a little more complicated, but we can just take the total probability 1 and then subtract the underweight and overweight to get the 0.9. So the general rule of addition is used when the events are not mutually exclusive. So joint probability is a probability that measures the likelihood two or more events will happen concurrently. So here you can kind of see, 0.6, 0.5, but then you notice how 0.3, sort of these circles are overlapping. So there's a 0.3% probability that, both of these events will happen. And then the general addition rule, the use of or is inclusive. So it's sort of like A or B or, both A and B, right? So what we're doing when we say that is we're accounting for the joint probability that is in both A and B, right? Because think about those circles overlapping. So what we do there, we'll subtract out the overlap so that we're not double counting it, right? So we can note that P, the probability of A or B equals 0, it means the events are mutually exclusive, right? And when I say mutually exclusive, that's a term you'll hear a lot in statistics. You'll also hear it in finance and accounting. We just basically mean that, this happens or this happens. They can't both happen at the same time. So what's the probability that a card chosen at random from a standard deck of cards will be either a king or a heart? So if the king, now obviously there's 52 cards in a deck, there's 4 kings in a deck, there's 13 hearts in a deck, and then the king of hearts, there's 1 king of hearts in the deck, right? So if you look at what we're doing down here, we've got 4 over 52 plus 13 over 52, and then minus 1 over 52. It gives us 16 over 52, and then that gives us the 0.30. So we could just say there's about a 31% chance. All right, thanks for watching this video, and I'll see you all in a future video. Take care.